First, I just want to welcome everybody. My name is Jenny Johnson. I'm the new chapter president for this year. Excited, looking forward to it. Just want to introduce our new board officers. Mark Starts, our new secretary for the year. Our treasurer, where is he? Jay Wynn. I think he might be out there. And then Winter Horrible's our new vice president. She's not here today. She's sick. Past president, Mike Holt. And then would all of our board directors stand? So this is your new board. So we're excited about this year. Have a lot of good things planned. Do we have any first-time attendees? You would want to stand up and introduce yourselves?
This is Marcy Early from Taylor's Engineers. She just started with us. She's from the University of Arkansas, but actually from Atlanta.
Yes, welcome.
Hi, I'm Prashant. I'm a student at Georgia Tech. I'm a member of the ITSGA chapter at Georgia Tech. And yeah, it's my first time and I love it.
Welcome. Nice. Welcome. Today's speakers will be Georgia Tech students, our scholarship winners from last year. But do we have any other students here with us today? If you want to go ahead and stand up, you can introduce yourselves. No one? All righty. And last thing we'd like to do is if there's been any recent job changes or promotions, just to kind of let everyone know about those changes. If you want to go ahead and stand up, you can do that as well.
David Olson is actually my first time in the ITS Georgia meeting. I just recently came on board with KCI to continue traffic signal operations.
Awesome. All right. Thank you. All right, so we have a lot of things planned for this year. A couple of new things with our communications and outreach. Bill Wells has been working really hard behind the scenes. We actually have the camera up here it's called Fuse. It's online streaming so that we can just provide the meeting to some of our peers in the Augusta area, things like that. But they'll be available, I believe, online afterwards, correct? For you to view as well. So, and also if you go to itsgeorgia.org, our new website has been completely redone. It's pretty awesome and it works phenomenally well on your cell phones too. So if you get a chance, check that out. Bill's done a great job with that. So you can check out the events, upcoming events, things like that, and just learn about everything that we're involved with. Legislative, Tom, do you want to provide a quick update? He's our legislative chair for the board.
There's, just want to encourage everybody, if you don't get the ACEC email, they keep you up on their website updates. There's a couple of things going through the legislature. Currently, everyone's aware of House Bill 170, the Transportation Funding Act. One of the benefits of that is the diversified funding for transportation in Georgia. There are 3 bills that are on the floor right now that are working to take small pieces out of there. House Bill 317, House Bill 364, and Senate Bill 58 are each trying to take a different part out of that funding stream. If it's something important to you about getting paid, getting projects going, be sure you hold your representatives, let them know how you feel, let them know what you think about funding transportation.
And going off of that, ACEC is having their legislative day on the 14th of February. So if you're interested in that, I'd encourage you to sign up. I know a few of us will be there from ITS Georgia, so it should be a good opportunity to network with them. Membership, Mr. James.
Registration is open. You all should have received an email invite middle of January. If you did not receive an invite for registration for ITS Georgia, please let me know. The deadline is February. After the February meeting, we'll start charging the non-member rates, so I encourage you all to sign up early. If you have any questions, you can reach out to me. Part of my membership is here. Carrie, walk out at the meeting. So if you have any questions, let me know. I'll try to get everybody signed up. Okay.
Thanks, Alvin. Networking and social.
Trivia tomorrow night at the Wing Factory. Come out and do better than I am.
It's a fun time. It's in Smyrna Wing Factory at 7. So it's a fun time. And we usually win too, so there's that. And I think that's all the committee updates. But if you're interested in getting involved on a committee, I highly encourage it. You can come talk to me or to any of our committee chairs. All of those are posted on our website. So yeah. And the annual meeting this year, actually, what we're doing is it's the 5C Summit. So if you remember, I guess it was what, 2 or 3 years ago, 4 years ago. Wow, it's been that long. We had the 3C Summit in Mobile, Alabama. This year, we're actually going to have the 5C Summit. It's going to be in Jacksonville, Florida. Florida, Georgia, the Carolinas, Tennessee, and then Grits, which is more of the Gulf region. So it'll be in Jacksonville, October 7th through the 10th. Go ahead and mark your calendars. It should be a really good event. So that will be our annual meeting for the year. And I want to introduce today's sponsor, Billy Stalcup with 360.
Thank you all very
He's
much.
the one that provided the delicious lunch today. So thank you for that.
I just wanted to say a couple things very briefly. First of all is we may have provided lunch, but we were not responsible for the cauliflower mac and cheese. I think it's really an exciting time to be in traffic right now. We feel very privileged to be involved with so many different cool and exciting projects, from smart cities to video analytics detection. It's really neat to be a part of this organization and what this organization stands for as well. So we have a saying that it goes: smarter traffic, innovative leadership. And we really believe that saying is, we want to provide smarter traffic solutions through innovative leadership. But a lot needs to be said about the area that we work in, because there's some incredible leaders, not only in Georgia for the agencies, the DOTs within this organization, but the leadership that we get to work with, all of you here, is phenomenal. So I just wanted to say thank you for allowing us to work so closely with you all, and we look forward to a great year.
All right, I'm Kerry Lord. So I was last year's scholarship chair. And so it's customary for our chapter that every year our scholarship recipients from the previous fall come and present their essay to us at the first meeting of the next year. So that's what we're going to do today. So we have 3 of the 5. The other 2 just couldn't be here. They had good excuses, so let's not hold anything against them for that. But we got some good topics here, and I'm going to introduce each speaker right now. So we're going to start with C.V. Pranav. C.V. is a PhD student at Georgia Tech. He's completed his master's in construction and infrastructure systems engineering in Tech and Bachelor Tech in civil engineering from NIT, Trichy, India. He's currently working on roadway safety topics, including pavement friction monitoring along curved roadways and characterizing driver behavior at work zones using laser sensing technologies and smartphone data. He's enthusiastic about intelligent infrastructure systems, automation and infrastructure services, GIS, and sustainability. He has a strong interest in marketing, entrepreneurship, leadership, and painting. So CB, come on up.
All right. Thank you, Kerry. I'm Sivi, and I'm a PhD student in tech, and this is my 3rd year. And I'm very thankful for the ITS for the scholarship. And today I'm here to present about mobility improvements, which I had presented in my essay. So let me go straight into it. Taking a while to load. So just a quick overview. I want to just throw some numbers which you all always know about it. And then I have this interesting analogy of relating transport to a human body. And then I want to just characterize some mobility issues and then throw some ideas on new IoT and smart city applications. And then I'll conclude with my closing thoughts. Yes, we know this. A lot of traffic, congestion, so much money being spent, and so a study by TTI in 68 urban areas show that they got drivers annually spend $755 or much more. It might change today, but the thing is, a lot of time is getting wasted, waiting, and also fuel is getting wasted, and we want to improve that thing. And how can we do that? The biggest challenge we have is the free flow, ensuring a free flow or mobility. And that's what we want to focus on in the next few years. Okay. This is my favorite bit. I wanted to relate the traffic flow with our circulatory system. So, you know, when the blood system is getting clogged, it leads to strokes. Similarly, when our traffic gets clogged, our cities are suffering from a kind of stroke, which is similar to our bodies, and we want to make sure that as doctors, from preventing city from going into paralysis. Okay, so if you're talking about mobility, it's important that we know what is restricting the mobility. So some of the few things that I could come up is, one is inadequate road capacity, and we want to see why it's inadequate, because since 1970s, our traffic is growing exponentially, 131% in VMTs, but the road miles, what we have, is just grown by 6%. Obviously, it's not going to help in improving mobility, and it's just going to lead to clogging. And the next issue with mobility as a challenge is the blockages due to crashes or some road events. Then we could also focus on bottlenecks due to construction activities. So when you take a part of a lane in a 3-lane highway, it's still reducing its capacity. So that's another issue with mobility. And finally, may not be a predominant problem, but is difficulty in accommodating multiple modes of transport. I come from India, and we do have so many different modes of transport, from bikes to buses traveling on the same road. And when they keep crisscrossing and they want to use the same space, there is some issues with regards to mobility or the free flow. So here I'm just going to throw some ideas, some of which I have gained through my knowledge and some of which I imagine. So there might be some operational issues, we can discuss it later, but the basic idea is to provide perspective from a service provider like a county or GDOT, how they can help improve mobility. So we all know the saying, what gets measured gets managed. So primarily we want to know what is happening, like when there is more traffic, what type of the traffic that we are looking at, and how many vehicles are traveling in that roadway. So we got so many new technologies in the last decade. We got radars, cameras, and even smartphones, which we can use the data anonymously to measure all the demands that we have on the roadways. And another thing that I wanted to bring up is how to be aware of events that's happening. We got sensors like cameras and radars, and we can keep monitoring what's happening, but one of the limitations with them is that their visibility or the range in which they can cover is limited by buildings and even other obstructions. So is there other alternatives to this one besides cameras and radars, which can be aware of the entire surroundings? So what we need is sensors which have wider coverage but can be used in a limited sense, like place it in one intersection but it can cover 3 or 5 mile radius. So one among them is using audio sensors, and combining that with artificial intelligence, we can make it more, we can be more aware of what's happening on the roadways. Why? Because audio is typically composed of frequencies, wavelengths, some phases, and the orientation. And if we can just combine them in different ways and start classifying them using some machine learning and artificial intelligence, it's going to be really helpful. And I can show you an example. So here is a figure that shows there's traffic flowing, and on the left there is a graph showing frequency and time domain, and we are hearing the sounds from the roadways. And at particular time when we see that new set of vehicles merging onto the road, they are going to brake, and if you can characterize that sound and that can be visible in the frequency domain, we know at this time, at this orientation, at this location, we have some event that's happening. And we can extend this to more events like crashes, and you can be much quicker in responding to such events. Okay, this is a very rundown, basic animation with what I believe is a combination of ramp metering and also fleet platooning. So autonomous vehicles are seen as, in the future, their efficiency comes by combining them together or platooning them. So if we can use both these concepts of ramp metering and the platooning for regular vehicles, probably we can space the vehicles such that when they keep crisscrossing, they don't interfere with one another. And there are so many operational challenges with respect to this concept, but it could be a good start on thinking how we can time the traffic lights to do a situation similar to this one. Okay, and when I was talking about construction bottlenecks, so that is one thing which we want to focus on is when construction happens, how long is the construction happening? If we can reduce the time in which the construction zone is occupying the road space, then which means we got more space for vehicles to travel, and that can happen much quicker. So in order to do that, we have to understand how the pavement is deteriorating. So the graph here shows the pavement deterioration, and if we are treating them much earlier, it's going to be maintenance, and we don't need to spend so much time, unlike for a road reconstruction where you have to block entire roads and take long time fixing them. Rather, if we can do short-term maintenances, let's say it takes 2 or 3 weeks, and we can keep that happening, we can ensure that there is less congestion on the long time frame. So how do we monitor what's happening on the roadway? So that is going to be some application of smart sensors which we can deploy. So I have two solutions on this one. One is understanding the characteristics of the pavements, and we can track them over time. And whenever we know it's falling below certain threshold in the conditions, we can go treat that, maintain that, instead of letting it go, fail, and then do a reconstruction. And we can also use our mobile sensors, accelerometers, gyros, etc. And when we combine them from a lot of people, we get so much data points, and using that and processing that, we can know where there is some distress on the road. For example, take potholes. So we know some vehicles are passing through that same location. We can see a huge bump in the accelerometer readings, and we can identify that location, and we can treat them much faster than somebody calling and reporting it. So yeah, I would now conclude my presentation here with a few thoughts. One, whatever I discussed earlier is mostly automobile centric. So it's like, if you got so many vehicles, yes, you can deploy all these methods and then you can improve the mobility. But that is not the only thing. We also want to encourage more transit for the people to reduce the number of automobiles. Reduce the number of automobiles, you got more space on the road. So how do we attract people for transit? So make them connected, make them a single pass. You start from here, door, and you want to get to the office place. At its door, you get all the transit facilities available with single pass. And also, you can do multimodal transfer on that. And finally, we are talking about IoT and smart cities, which means there is so much data needs in it. And it's very essential for the government or the private players in ensuring mobility to have a very strong data infrastructure for their success. And with this, thank you for listening to me, and any questions, I'm open.
So I failed to introduce the Georgia Tech ITS Student Chapter President, CB, when I introduced him earlier, so I want y'all all to know him and you know them. You know, we appreciate you being willing to do that, and we're here to support you 100%. So
Sure,
thank you so much. Okay, did anybody have a question? Brian Mulligan, you don't have a question? Does anyone have a statement? Thank you very much. Appreciate it. All right. Okay. Our next speaker is Anirban Chatterjee. Anirban is a PhD student at Georgia Tech studying computational science and engineering with a specialization in transportation engineering. His research focuses on the application of computer vision technologies for road infrastructure condition assessment. As a graduate research assistant, he develops algorithms and software for GDOT to improve the road condition survey operations. So, Anirban, if you can come on up. Thank you.
Right. Good day, everyone. I am on the same research team as CB, and CB just talked about the more broader sense, the basic ideas of smart city infrastructure applications and what we can do with IoT devices. I'm going to talk more specifically about some examples, how we can apply them. And all of the projects that I'm going to talk about have been implemented by our research team by undergraduate students. The VIP program is the Vertically Integrated Projects Program, which has been deployed in over 200 universities. The basic idea is undergraduate students become a part of our research team. They receive course credits, and our research team gets its work done. And our research team is called the Smart City Infrastructure Research Team, led by Dr. James Tsai at Georgia Tech. Right now, this VIP team is on its 4th semester, and we have about 10 UT students every year from different disciplines. ECE is the most involved, electrical and computer engineering, and also computer science, industrial engineering, mechanical engineering, and of course, civil and environmental engineering. So I'll go over 3 of the projects that have been completed by our students. The first project is the Curve Finder. FHWA wanted a simple solution for evaluating where the curves are on the road and do they follow specific guidelines for curves. So one of our undergraduate students designed this web-based application which detects and analyzes curves from GIS data. And the beauty of this is it's really flexible. It's a web-based application. As you can see, it's running on Google Chrome. So you can use it anywhere, and it accepts inputs of any type. You can use your shapefiles. You can use a CSV file collected from a smartphone GPS points, or you can use YAML files, which are used by Google Earth. once you enter it in, it just makes sure that this is the right curve. So this is straight route 2, and then it automatically processes it, and all those green spikes you see over there are the detected curves. So you can enter different parameters, what constitutes a curve, what's the maximum minimum radius that a curve can have, and it'll get all the properties where the curve is, what's its radius, what's its deflection angle and length. If you provide information about the design speed and friction, it will also tell you how much super elevation you're supposed to design with this curve. And of course, it's interactive. You can click on any curve, it'll tell you exactly where it is, show you its properties, and so on. And at the end of it all, of course, you can export the data into a CSV, so you get a neat Excel spreadsheet with all your curves and their properties. The next project is the visualizer. So this is an internal project that we are developing at Georgia Tech. We are trying to collect road condition information using different devices. We have a survey vehicle with laser scanners at the back, like the ones you see at DRB. We are also trying to collect road condition information using more innovative methods, such as using smartphone accelerometers or simply using the GPS collected by smartphone devices, GPS data collected by smartphone devices. So we need a common platform to show all this data. Smartphones are obviously less accurate than the $100,000 devices we have on our smart sensing van, but we can use techniques such as Bayesian inference to increase the accuracy of the smartphone data. If we already know what the IRI is at a particular road segment, we can calibrate the smartphone algorithm to have better results. So that means we need a common platform where we can have all of this data. So this has been in development on our research team for 1.5 years. It's also a web-based application, so you can view our data anywhere. It's actually available on the internet right now at sci.vip.cartech.edu. Right now, the dots you see over here are it's cracks, I believe. Green means less cracking, and red means more cracking, according to the CoPace's manual from GDOT. The final project I want to talk about, this is a more sciencey project. We are using laser scanners to analyze the texture of asphalt pavements. So we have a better understanding what causes the raveling, what causes potholes to occur, and how can we more easily measure them. So we wanted to find out how accurate actually different laser scanners are. And one of the things we did is this robotic arm you see over here is actually a Faro laser scanning arm, which we had at the Invention Studio at Georgia Tech. The way it works is you can put any object in front of it, like I can put this laptop over there, and slowly move this arm to scan it, and it'll generate a 3D model of that item. So then you can 3D print it, you can analyze it, etc. So we decided, hey, why not use this arm to analyze pavements? So we just took this arm, pointed it at a sample of the pavement, and got a really detailed 3D model. So as you can see in this model, you can actually see the individual aggregates of the asphalt pavement. And we can use this for calibration and validation of different laser scanners to see how accurate they actually are. And these are just some of the examples of innovative uses of technologies which we don't necessarily associate as transportation technologies, and use them to develop more smarter applications for the maintenance of our road infrastructure. That's it. In conclusion, I would like to state that what we hope to achieve in the long term using the VIP program is that, as I mentioned, most of the students in this program are from different departments. C is actually the minority in our VIP group. We have students from ECE, from CS, from mechanical engineering, and now they're working on transportation problems. We hope that in the future, this will inspire them to be more involved in transportation and help in the betterment of the transportation field. Thank you.
Any questions? Somebody got a question? Y'all are scared to ask him a question. Yeah. All right, that's good. It's funny that you said that about the different types of education and professionals entering our industry, because that was a discussion in our board meeting today, and we're certainly acknowledging that in our ITS chapter. So it's, you know, and I think that we've always been very open to that, and we'll continue to be that. So thank you, man. Thank you very much. All right. Okay, our third speaker is Haobing Liu, and Haobing is a fifth-year PhD student in civil engineering at Georgia Tech. He also obtained a master's degree in statistics at Georgia Tech in 2017. Haobing's research focuses on transportation, energy, and environment modeling. And Haobing, come on up.
I want to thank ITS for providing me the chance to do the presentation here. The topic is urban mobility in the era of smart city and Internet of Things. So 3 keywords here, mobility, Internet of Things, and government. So this is the question we got for the essay. What smart city applications or Internet of Things technology can government utilize to improve the overall mobility in the urban regions? Here I want to list some examples from improving the traffic operation, transit, parking, walking and biking system. So now with the large amounts of GPS or camera or road detectors available to gather the information, it enables us to get large-scale information, and we can generate a series of indexes that can reflect the overall transport network operations. And this graph is from the result we conducted showing the hourly VMT and the speed distribution of MATA buses and the hourly on-road vehicle energy consumption and the air pollution that are related to the vehicle emissions. So with the big data from the Internet of Things available, we can generate such large-scale operation profile in real time, or even do the short-term prediction, which is very helpful to support the design or implementation of strategy to alleviate congestion or air pollutions. And with the capability of the computing, with the computing capability to process the big data in real time available, so we can also come up with a real-time monitoring, evaluation, and decision system. And we think the smart traffic signal can be incorporated in the system, and also the local police or the emergency services can also benefit from the real-time processing system and rapidly respond to the incidents. So this is the traffic operation. The next is the transit. The Internet of Things technology can also be utilized for the transit agencies to improve the transit operation and management, at least in these 4 aspects. The in-vehicle sensors can be coordinated with the smart traffic signal to implement the transit priority strategy to ensure the transit can be operating on schedule. Also, Internet of Things technology can also help in the implementation of the eco-driving by monitoring the real-time fuel consumption, driving behavior. The drivers can even get reminded if the hard accelerations are detected too frequently, which is not very fuel efficient. In terms of the transit fleet management, the in-wheel sensors can also monitor the up-to-date, the daily working status of the vehicle, and those informations can be automatically delivered to the data control center for the comprehensive evaluation, and then the maintenance or repair, if needed, can be arranged ahead with significant savings of cost or the labor. And also the sensors in the bus stop or rail stations can also monitor the real-time passenger demand, which is especially important during the peak periods or for the special events. So parking is usually very painful in large cities. A case study that measures the traffic in Los Angeles 15 block area in 1 year shows that drivers drove 950,000 miles, produced 730 tons of greenhouse gases, and used huge amounts of gas just looking for parking in 1 year. I think we can, the government can make the citizens or visitors' life easier by applying the Internet of Things technology into the smart parking. So the sensors embedded in the parking spot can monitor the real-time status of the parking spaces, and those information can be compiled together into data center and linked to smart devices. So drivers can identify available spots and reserve it with a fee before they really drive there. So I think this has the potential to minimize the traffic congestion and reduce the emissions. So pedestrian safety. One technology that is very easy to implement has been used in Finland, where the pedestrian, especially the children or elderly, can carry a small wireless reflector, and when they are crossing, the reflect can be detected by the on-road detector and make the blink to alert the drivers. And this technology can further involve the smart traffic signal to alert the turning drivers, especially the turning truck drivers, when the pedestrian is crossing. And also, sidewalk is one of the most critical multimodal transportation infrastructure. A Georgia Tech team led by Dr. Randy Gensler has developed a smartphone app. It's called Sidewalk Scout to enable people to record and report the sidewalk quality. So researchers can work together with the community members to record and collect and upload the sidewalk data, like take a picture of sidewalk quality and upload through the smartphone app, and to achieve the goal of creating a database of sidewalk quality. So the government can use the database to maybe prioritize the sidewalk maintenance and repair. And this database can also be used by the pedestrian for the routing decisions. Bike sharing has becoming more and more popular as a sustainable and flexible traffic mode. And people can use the smart devices to locate a spot and the bike available nearby. But the flexibility of the bike sharing system comes with the challenges of the dynamic demand and asymmetric usage, which might lead the bike distribution a difficult task. So with the Internet of Things technology, bike sharing system, we can provide the real-time bike supplies. For example, if there is a biking lot that are experiencing very high demand but not enough bikes. So operators can implement a discounted fare strategy and encourage people to rent from spot with surplus bikes and park in the spot with potentially higher demand with less supplies. And these are the references. Thank you.
Thanks, we really appreciate it. And thank you all three, gentlemen. Just a note worth knowing is if you're a student, this next year, come fall, we're going to have another scholarship application. This board has been very generous in the past, so we would encourage you to look out for that. We'll certainly be in contact with any of your Georgia Tech professors to make sure that application is well advertised around.
Thank you guys. So just a couple of quick reminders for some upcoming events. Tomorrow night, trivia in Smyrna, 7 o'clock. Be there. ITS 5C Summit, October 7th through the 10th in Jacksonville. I don't think registration's been posted yet.